Today is a little different. We're not going to do 10 small examples. We're going to do one big example. One example that's going to stretch the entire class. If ever you kind of get lost and you get frustrated with your own code and you want to catch back up to where I am, you can always just like copy and paste the same link that I gave you originally, and then you'll be up to date with where I'm at. It'll come from this new REPL. So let's enhance, 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 and let's get to it. So today is about classes, and today we're going to be modeling two classes, an orange tree and a tree. And then towards the end we might add other types of fruit trees. As we went over last time and as you learned in your homework, a class can be thought of as kind of like a type of, kind of like a type of object. So instead of, if you wanted a cat, instead of every single time saying, listing out the properties, if you wanted a has clause true, and then if you have a new cat, classes make this easier, where you can create an object, a class object, which will always create the same structure of an object for you. So that's one of the advantages that classes give you over just regular objects. So let's look at our orange tree. This is our overall instructions for what we're going to try to accomplish this class period. And most of it is going to be happening over in the OrangeTree class. So if we click on OrangeTree.js, we see a whole bunch of code. We see lines 1 through 46, which is a declaration of the class. And then we see at the bottom module.exports OrangeTree. So we're exporting OrangeTree from this module. With the class, if I go back to index.js, when I call this new keyword, which function is that calling? The constructor in what? The class that follows it, right? So if I say, give me a, if I say orange is new orange, then the new keyword is going to call the constructor within orange. But in this case, like you said, I'm calling new orange tree. That's going to run the code inside the constructor of new orange tree. And before we get started, we can prove that by running the code inside the constructor. So I ran the index.js, it said new orange tree, and it ran the code inside the constructor. Inside the constructor is also where you can set properties. So our orange tree is going to start from a seed. So for us, that means it should have two properties. It should have height, and it should have age. Now, if it's a seed, we're going to say the age is 0, and the height is 0. And that's going to be every single new tree that we create, the age and the height are going to be 0. And now once we have that code, we're going to go back to index.js, and we're going to validate it. And we're going to console log the tree we have. And we console log that tree, and it looks like an object, except it has this orange tree declaration at the front. And so it says age of 0, height of 0. And whatever we put in that constructor, if we were to say age of 100 and run the code once again, it would appear in this object when we're printing it out. So that constructor is setting properties inside the object, inside that orange tree class. And like I said before, the cool thing about classes is you could say, you could keep creating them. Which is really helpful if you have to model 2 or 3 things, but it's really, really helpful if you have to model 100 things or 1,000 things. This is what we call, keeping your code dry, not repeating yourself. That's one of the advantages of classes. So we can console log out tree and tree 2. And they should look pretty similar. I wonder what would happen. Are they the same thing, though? Like, will this be true or false? Why not? Look at them. It's like the exact same thing. I'm going to run it, and it was false. So even though they have the same object structure, they are technically different things. They are not equal to each other. So if you really wanted to compare, is the height of tree 2 equal to the height of tree 1, you'd have to do it with their properties. And something like that would be true. You can't do it with the actual object themselves. So let's all go together to OrangeTree and let's fill out the growing season. And let's actually just fill out line 13 of the growing season. So line 13 in my instructions say, for every growing season, the tree should age 1 year. So every time someone calls past growing season, we want the tree to age 1 year. So we can say this dot age equals this dot age plus 1. And that's going to increase the age by 1 every single time we call past growing season. And before we go in and add the rest of these, let's go to our index and try it. We could say tree.pass growing season, call it as a function. We run it, but we didn't print anything out. And we can console log our tree to the screen. And you can see our tree, our age has increased by 1. If we were to do it again, you'd think our age should now be 2. And so every time we call that past growing season on the tree object, we're calling this past growing season function. And every single time we're increasing age by 1. And that's going to be true of all of these functions. All of these functions you can actually call on the tree object. And you can't call them any other way. You can only call them on the tree object. You can't just come in here and say, well, past growing season. It's going to say, I don't know where that's coming from. It's not attached to anything. And you also can't say, oh, well, it's in this module. I want a past growing season. It's not a function in that case. So it's actually an instance function. And what an instance function means, it can be run on an instance of the class. When I call new OrangeTree here, line 3, that is an instance of the class. So go ahead and you can take 2 minutes and complete lines 14 and 15 and line 14 in my code up here. So a tree should grow 2.5 feet taller until it reaches its maximum height of 25 feet. Go ahead and take a minute and a half and do that. And then prove it by printing out the tree over an index. So in that growing season, we want to be increasing the height every time. People differing on where to have that maximum of 25. Should it be in index or should it be in class? Just 20 more seconds here. All right, so for mine, in line 4 and line 5, I'm passing 2 growing seasons. So before I even write any code, when I console log out in line 6, what I should see is I should see OrangeTree age 2 and height 5, right? I should be growing 2.5 each time. So the first thing I would do is try to get that to pass. So I would say, okay, every time I pass a growing season, I want to take my height, and I want to set it to what I had before, plus 2.5. And now I'm going to go back to my index and run. So I had a tree. The first growing season, my tree was 1 and 2.5. After the second growing season, my tree was 2 and 5. Now, because I want to test my logic, what I really wanted to do is only increase it. Oops, that's the wrong one. I only wanted to increase it until it hit 25. So just to see if this is going to work, I'm going to say while, I'm going to set let I is 1. I'll do a for loop. How about that? So you don't have to do this in yours, but I'm just going to run 100 years to see what happens, right? And for every single year that I run, I'm just going to print out how old and how high is the tree. And we should see a ton of numbers print out here, right? So, but every single age that the tree grows, it goes up 1, and it goes up 2.5. So that's a little bit higher than I wanted it to go. So what do I need to do inside my, or how do I get it to stay at 25? Yeah. So you're saying, okay, something like that? I got a bunch of 27.5s now. Right here? It is greater than or equal to. Right here? Okay. I'll run it again. I got a bunch of zeros.
That statement needs to be underneath when you add.
So it needs to be this height equals this height plus 2.5. And if I wanted to be even a little more clear, it could say, hey, if the height is less than 22.5, then this height is equal to this height plus 2.5. Maybe something like that. That way I'm not setting something just to reset it. Okay, so that makes sense to me. And look, my tree keeps aging, but it stays at 25 feet. It never gets older than 25 feet. I liked your idea of putting it in OrangeTree. Why could I not just say here, you know, something like if tree.height is greater than 25, is not greater than 25, then grow. Why couldn't I just do something like that?
Then it wouldn't age.
Yeah, because then it wouldn't age. Oops. Yeah, exactly. It wouldn't age. Or if I messed up that here, it would run forever, right? It's going to be 0, 0 the whole time. For every single year, it never actually would grow in age because I'm never calling past growing season. All right. Number 13, past growing seasons until a tree is mature. Line 13 on mine, instruction number 1. So that's going to be the first thing, like the first piece of activity we're going to try to do. So what does it mean when a tree is mature? Yeah, fruit bearing. So in our case, that's 6 years old. So we're going to pass growing seasons until that tree is mature. Go ahead and take 2 minutes and do that. And in OrangeTree on line 15, you find the 6-year-old requirement for a tree being mature. And if you want, there's even a function you could use called isMature. There's a whole bunch of different ways people are solving this. I see a few people using a function, some people just doing it in the past growing season. Yeah, that's kind of a personal preference. I would kind of like yes or no. All right. So I'm going to solve it how I would, and there's a whole bunch of people that solved it in different ways. So what I would probably do is I think, okay, if this maturity of an orange tree is going to be important, I would probably say every time I initialize an orange tree that has an age of 0 and a height of 0, that tree is not producing any fruit. That tree is not mature. So I would say this mature, and I would set it equal to false. So now my tree has an instance variable where I can always just say, I can call .mature on it, and I always know, is it true or is it false? I don't need to figure out some fancy thing. So this mature is false when I start off my constructor. And then when I pass my growing season, I could say, in another if statement, I could say, if this dot age is greater than 6, then I want to reverse, and I want to say this mature is equal to true. Yeah. That was good, yeah. Thank you. Yeah. greater than or equal to 6, this mature equals true. Okay, so now we're going to go back, because we just coded a lot, we're going to go back and see what happened, right? So if we write a for loop, and we say, go until you hit 7, like go 7 times, then what we should see, if we pass 7 growing seasons and log it out 7 times, we should see a tree not being mature 6 times, and on the very last time it should be mature. So we could say tree.pass growing season, tree age, tree height, tree mature. And age 1, false. Age 2, false. Age 3, 4, 5, 6. 5 is false, and then 6 and 7 are both true. So that's working as we expected. Yeah.
Did you initialize the tree mature then equals false? Was it in the function?
Yeah, so if I go back to OrangeTree, the question was, when we initialize mature equals false, we did it in the constructor. Because we're just saying, like, when a tree first is planted, it's just not mature. There's another way we could do this. And I saw somebody else do it in this way. We could add a function called isMature to our actual tree. And how do we know if our tree is mature? Well, the this.age is greater than or equal to 6. And we could add that just as a function here. And then in line 26 through 28, we wouldn't need to set mature. We would just always be able to say, okay, is it mature? This.age is greater than 6. So I'm going to do a small refactor of my code where I'm going to delete lines 26 through 28, delete the setting of mature, and then I'm going to delete setting mature at all. And so now when I want to check if it's mature or not, instead of setting a property on the tree itself, I can just add a function that says, hey, is the age greater than or equal to 6? Let's see the difference that would play out in our actual code. Instead of saying tree age, tree height, tree mature, we would just say, we would call that function. We would say tree.isMature. And then every single time we print that out, this function, tree.isMature, is going into here, and it's saying, is the age greater than or equal to 6? And it's returning that as a Boolean variable. So we should see something pretty similar. Yeah, exactly similar. The only difference is it's a little bit less code, and we're using a function instead of setting the variable inside past growing season. Are there any questions on this before we move on? I realize that was a big shift right there. All right, line 15, still on, obviously on my code. Instruction, a tree should bear fruit if it is mature. A tree should bear fruit if it's mature. Between 100 and 300 oranges of fruit. How would somebody, can anybody, before we release everybody to do this by themselves, how would somebody go about that? Yeah.
You could do the random number and with the, I forget the name, but the floor or the ceiling to give it a particular range, and then just let it call a random number between that.
Okay, so let me pseudocode it out here. You're saying generate a random number between 100 and 300, right? And then do what with it?
Well, in order to generate a random number, you gotta do the map dot floor, ceiling, and
Yeah.
and then just assign that as
And then, okay, but be a little more specific. Just assign that as a variable.
the number that is generated, and then this dot fruits equals that function, and then have that function return that random number.
Do we always do this?
No, only if it's 6 or above. So all of that goes within
if the tree is mature, generate a random number between 100 and 300 using Google to find out that math floor, math ceiling thing, and then assign this dot's fruit to that generated number. I like it. 2 minutes.
Did you use the orange class? Cool. It's greater than equals 6. You don't need to say. And then the other, other than that, it looks right. And then the other thing I would say is this like 6. What I would storing the constant on top. That's like const mature equals 6. And then reference the constant. And then if somebody else comes in and wants to change it to 7 or 8, they know where to look. That's the last instruction on the first page.
Okay, yeah. So there would be.
Yeah, that's the last instruction on the first page.
Oh yeah.
As you still have a minute left, but I'm going to look at this random number thing too.
So I spent actually a bit of time working on that. I can tell you the easy way to sort your way through it.
Well, I'm just mimicking
Oh,
how I would go about Googling it.
yeah.
This doesn't look right because I'm just generating using a tool. Only works if the minimum value is 1. Okay, that seems doable. For people that are struggling with the random number generator, it looks like this one will work.
Use trunk, not floor. You could potentially, incidentally, keep yourself from reaching the top of your list if you use that. Trunk just pops off the last decimal, whereas floor could actually round you down to lower you want to be.
Okay. It's a tree.
Yeah.
There could be exactly 300, but that's valid, yeah.
I spent some time figuring out how to do random numbers because I like using them. So probably spent too much time reading the right way to generate those numbers in JavaScript.
All right, 30 more seconds.
So has oranges just returns true or false. Does the tree have oranges? But where the tree actually gets the fruit is during the growing season. That could be yes. Oh, don't do that.
All right, following our logic, I'm going to continue coding up here. If our tree is mature, for some of those who still have mature to be a variable, it'd be like this, right? But I have my function, which I can call. So I could say if this dot is mature, then what I want to do is get a random number of fruits. And I'll console log that random number of fruits out. So I should see, right, it's only mature after age 6, so I should see ages 1 through 6 not mature. Unexpected token. Does anybody see it? Right here? Yeah. And even better, right, we don't need to do this. We can just console log the tree itself. And we see all these tree objects printed out. Age of 1, height 2.5, age of 2, okay. And then towards the end, when we get to age 6 and age 7, we start getting oranges. So then we want to set a property on the orange tree called this.fruits or this.oranges, one of the two. I like the idea of fruits. So we could say this.fruits equals.
What did you just change to fix that error you had?
Yeah, I had an extra parenthesis right there. Mistakenly. Are you running into the same error?
I got the same error and I have no idea where.
Yeah, I mean, what the error was saying was that you have an extra parenthesis somewhere. So now when I add this.fruits as an instance variable, now when I print out OrangeTree, age 1, height, it keeps going up, and then fruits, there starts being fruits each time. How come I don't do this? Like I did with age and height and all the rest of them. How come I don't do that? Because that's what I did with height and with age, right? I added to it every year.
It says it drops off every year.
Okay, so it says to reset it to 0 every year. Okay. Can anybody also answer why that's NaN, not a number on the right side? Because we should have seen it keep increasing forever if you're right. Why was it NaN? Yeah.
You're never initializing it in the constructor, so it's not defined.
So what should I should in the constructor I should say there are no fruits. There are 0 fruits on this tree. And which is fine because someone could go like set a fruit on the tree and you still have to add it, right? You don't want to have it be undefined in case you want to access it. Okay, so it seems like we have met all the conditions of past growing season. Increase age by 1, increase height by 2.5. If it's mature, add some fruits to it. We've completed is mature, where we say the age is greater than or equal to 6. Let's add an instance method has oranges, which returns just whether or not the tree has any oranges. So what would that be? That could be has oranges. And we would just turn if this.oranges is greater than or equal to 0. And that'd be another way of saying like, hey,
No, you don't want equal to 0 because then it would return true when you have no oranges. You would want just greater than 0.
this.fruits is greater than 0. So there's two things that we changed there. One was that I was calling this.oranges, even though we set the property as this.fruits. And then the other thing is that it couldn't be greater than or equal to because it needs to be greater than. We always have 0 fruits. So if we wanted to, we could call, we could say in our index, we could use that exact same thing. We could console log tree.hasOranges. And it's false, it's false, it's false, it's false, it's false, it's true. And then once we now have fruits on our tree, we can call hasOranges, and we'll get access to that. Okay. continuing on in OrangeTree, harvest an orange. Should pick an orange of the tree and return it, or throw an error if there are no oranges. I think I'm going to leave this as a stretch challenge. But for those of you who are interested, what harvest orange involves is instead of assigning a random fruit as a number, it's to assign a random number of this orange class. So you would have to import orange into OrangeTree, and instead of like a number like 189 being your random fruit, it would be 189 orange objects. And then the pick orange is saying, hey, give me an actual orange back. That's here. Let's just do 1 through 4 in our code, and that'll take us right through the end of the lecture. So number 1 says pass growing seasons until a tree is mature. So if we have that is mature function, we could say while tree.isMature, or in our case, why a tree is not mature, we want to tree pass growing season. So instead of hard coding 6 now in both places and waiting for it to be mature, we're just saying, hey, while it's not mature, keep passing the growing season. And for each one of these, we can pass out the tree. So we console log the tree each time while it's not mature. And then when that's over, when a tree has matured, print tree matured. So we can console log tree matured. For number 3, we're going to do another 4-minute exercise. Go ahead and for every season that a tree is mature, print the past growing seasons, and then print the tree for each one of those, including the age, the height, and the oranges for each season. So go ahead and do number 3.
Can you scroll up back to the random fruit function, like if this dot is mature? Yeah.
So as people are working, the question was to go over lines 26 through 29 on my code. And so what it's saying like, hey, is this tree mature? Which I'm going to delete this just for a second and add it back in. I could write a different way, right? I could say if this dot age is greater than or equal to 6, because that's the same thing as being mature. Then what we want to do is we want to get a random number between 100 and 300 and set it to this dot fruits. Cool. I'll come right over there as I walk around.
Oh, cool. Where are you coding this? No, sorry. Where in OrangeTree?
Oh, sorry. Under the isMature function.
So actually, the isMature function ends on line 36. So it looks like you're just kind of coding it in the middle.
Oh, so put it within the.
You can either put it inside isMature, or you can put it up here in past growing season.
Oh. Okay.
So like mine, for example, I have it in past growing season because every growing season is when you want to add fruit to the trees.
But then it won't recommend the isMature function.
Yeah, good one. I think you might have to worry about, vegetation.
Yeah.
Things, but this is on the right track. Yeah.
You know, like how to fix it. That's like I always.
Yeah. So everything inside a block should be one tab in. So line 27 should be a tab in. And line 28 should be a tab in. And then the block, which is the other closing parenthesis, should end on the statement. Or should be tabbed into the
Yeah.
Okay. So it's like that. Yeah. Now only other thing I would add, the only other thing I would add is that it's not immature is a function for you're just calling it, so you need to call it as a function.
Thank you.
Yeah.
Okay.
Yep. So for step 3, it's just saying for every season a tree is mature, pass a growing season, and then print it out. So all it would be is while tree is mature, we want to console log the tree. We want to print that tree out, which for us, unfortunately, is going to be forever, right? We haven't set any. Now we're at, age of 6. Why is my code stuck at age of 6?
Because you're not adding a growing season each rotation. It's just console logging your tree, not tree dot growing season. Say console log that tree.
So I'm just in a loop instead of actually passing a growing season each time. Okay, so now my tree is old. 9,300 years old. So in our case, there is another instruction that says, hey, only keep the tree being mature until it's 100 years old. And then at being 100 years old, when we call the tree dead, then it's no longer mature, it's no longer alive. So there is another class method isDead where you can add that function and then use it. The part that I want to get to right before we dismiss to Studio is the idea of line 22 on mine, the idea of refactoring the OrangeTree class into saplings. So a sapling is just like a baby tree that's already grown for a few years or grown for a year, right? It's already got a few feet and a few ages to it. So in order to do that, our orange tree would initialize when we planted it with a age and with a height, right? If we were going to plant a sapling, we would say when we build the orange tree in our orchard, it comes in with an age and it comes in with a height. And the only reason we're going over this is to show that instead of setting the properties in the constructor to 0 or to a value you initialize, you can set them to values that are passed in by the constructor. Now, I think we went over this last class. If I have properties in the constructor, then where do I need to supply them? Yeah, when I call new orange tree, right? So I can say, hey, I got this orange tree, and it starts off at being 3 years old and 7.5 height. And our orange tree only, while it's not mature, only passed 3 growing seasons because we initialized it to be 3 years old and 7.5 feet tall. If you're looking for a few stretch goals, go ahead and do 5, 6, and complete the orange tree class and complete the orange class. Other than that, if you have questions, raise your hand. Other than that, we're going to dismiss. Other than that. Thank you.